And I am live. That is pretty nice. Today is 23rd of October 2025, Wednesday. Shit, and today is Thursday, and today is 23rd. 23 is a prime number. If yeah, I think that was important somehow. Yes. And yes, let's begin. And I just want to say yesterday I didn't debug. Yesterday we had a bug in our code which I didn't fix off the stream, so I'll have to do it now. Pipeline tester, and should we have the server running in this window? And let's okay, event loop code is pretty amazing, and I think that the problem lies with how the server is writing to the client socket. Right. Yeah, and let's investigate that part. Okay, there is some error somewhere. Okay, this is application.cpp. Yep, handle except. I think right. Yes, this function. If n is smaller than want to close, yes, want to close is true and want to write is false. And also, we would say want read is also false. Like we don't want to do anything in this case. And is this function running correctly? Wait, okay, no, I think this is running correctly. Uh, P error because yes, we are erasing. So we do know that the server is erasing the output buffer. So we are getting to this line and we wouldn't be getting to this line. We are returning here, right? And also we are returning here. So yeah, we are writing the thing and is not smaller than 0. So that is a good thing. I think we don't even need this line. Like why should want write equals false if we have written the whole thing? Yes. Yes, want write equals false if we have written the whole thing. Or instead of this, after erasing, we can check the size of write. Write dot size. If size is 0, then yeah, there is nothing. We don't want to write anymore because there is nothing to be written. Else want write equals false. Okay, all of this seems cool, like pretty cool. Hello, CPP book name CPP. You can go to the C++ programming language by Mr. Bjorn Stroustrup. This book and shit. This is the guy. This is the man. Yours right there. Yep, this book. And this one is edition 3. The latest one is edition 4, and it is on C++11. So, but the latest C++ version is 23, but still, you will learn quite a bit from it. Hey, can I ask you why you are coding in Vim and not an IDE? Okay, yes, because in Vim, I know what is happening. I know that there is this thing called LSP which is running, and the LSP was configured by me. Client D, I just downloaded it and enabled it. That is all I did. So I know that there is this thing called LSP which is running right now in my code editor, and I also know that there is this thing called tree sitter which is running, which I see on the right. So I know what is happening in the code editor. So first of all, this is not bloated. There is not a lot of extra things. Second of all, I know exactly what is going on, like transparency. And third of all, I can do whatever I want with this. Like here, let's say when I'm doing competitive programming, let's say code.cpp, and in competitive programming, the boilerplate is same for all the codes that I write. So I can just press space BLP and the boilerplate is here. So yes, you can do a lot of amazing things in Vim. And not just this, let's say I am running my thread server. Nope, I'm running my event loop and I want to compile this and see the output. I can just do this, which is another command. And here, like you can configure a lot of things. I here pressed space CMP, which is a command I like wrote manually. And this thing compiled in this much second, the current file which I was editing, and started executing the thing. So yeah, yeah, it is amazing. And the freedom that we get is quite crazy. And you know what is happening. So that is cool. And also this thing, you can have plugins which are amazing. This is a plugin called Harpoon by the Primogen, Michael B. Paulson, this guy, Primogen, and this is pretty cool. You can use this to switch between files very, very quickly, like blazingly fast, like this. So that is pretty cool, like that. Shit, that is pretty cool. And the power that you get with Vim is amazing. Just the speed of editing is also pretty fast with Vim. Yeah, Vim is cool, like pretty cool. And of course, the main reason why people use Vim is so that they can say, I use Vim by the way. That is literally the main reason. And okay, but yeah, you still need debugging skills to debug things. Application code, process payload, handle accept. So I think the right function is writing correctly. So that is nice. G plus plus event loop server, run the server. So the server is always running now. And we can event loop pipeline tester. Yeah, we have to run this thing, but we get error. Okay, this is literally not doing anything. On the server side, we got client says first, then client said second, third, fourth, and then connection with client is closed now. But on the client side, we didn't see anything. So something is wrong. The client is not receiving messages somehow. Shit, the client is stuck in an infinite loop, which we saw here. Return -1. No, no, no. Write all. Nope. The problem is with read here. Read all. No, no, no. Here when the client is read from this socket into this buffer. Here we have the read from function. This parses the length, right? We are calling the parse length function, which is right here, and here's the problem somehow. Wait, yes, we are not even getting this. So what is happening? Length. We are calling the parse length function. Shit. Okay, my bad. I should not have banged the table, but shit. I think I get the problem. Okay, shit. Okay, okay, okay. I get the problem. The problem is print ID IP address of the client. Okay, I'll do that in a minute. The problem is this. We have the server, or let's say we have the client and we have the server here, right? And the client, since this is pipelined, the client sends a request and does not wait for the response. The client sends another request, the next one, and yes, and the server keeps sending the responses, right? Pretty cool. And the client is in such a way that it is not listening for any incoming requests unless it has sent out all the outgoing requests. And the thing is, while client is sending these requests, the server is processing and sending the responses as soon as it can, right? So after, when the client is sending this last request, the server has already sent in the response for this request, maybe for this. And also there is a buffer when the client sends the last request and starts to listen for response. There is a like small time, right? And maybe in that meantime, server has sent out all the requests, all the responses. And the thing that server is doing is server closes the connection when it has sent out all the requests. So that is kind of crazy. And I think that is the source of our problem. The server is closing the connection after sending out the last response. And that is not very good, because when client is listening for these responses, the connection is closed. So there is nothing to be listening on. So yes, shit, that is bad. And I think we can fix that if we tell the server not to close the connection, which is easily doable if we don't send this exit command. Okay, now it might work or it might not. Shit, yeah, this still doesn't work. Yeah. Are we coming into this function printf I plus sv, or we don't need printf sve? See out hi there, include our screen. Okay, okay, we are not even calling that length function somehow. Okay, and our server is all still listening. The event loop is still running. That is pretty cool. Okay, so we are not even calling this function. Why? Read from. Are we not even calling the read from function? Uh, okay, hi there was printed out twice. And the second hi there came from this place. So this hi there, if here it was being printed, but here it was not being printed, so something is wrong with the pass length function. We are okay getting deep with binary search. While rem greater than 0, greater than 0, let's output rem. And line, okay, okay, it is persistently equal to 4. So which means n is always equal to 0, which means we are unable to read anything. Read all is messing up. Okay, we have read all right here. N is how much we want to read. Require is What is requi? Makes sense. What is requi? We write all parsing. Okay. Okay. Then it is always 4. Wait, shit. Wait, rec RV is always 4. So we are reading something. We are reading something. Okay. So is n not decreasing? RV is equal to 4. So we are able to read 4 things, which is what we wanted to read. So what is the problem here? Uh, uh, let's print n in that case. Again, I think there's some problem with the way that we are compiling the application. Uh, uh, Pipeline tester output client dot slash client. Okay, why do we see 4? Let's stop the server. Unable to read connection reset button here. Okay, dot slash server. Run the server here. Run the client here. And why do we see 4? Okay, 4 does not make sense. Pipeline tester. Yo, hello. Do your YouTube channel contain a playlist for beginners in C++ and your YouTube channel contain playlist for beginner for C++? No, it doesn't. And if you want to get into C++, I mean, it depends. If you are a beginner to programming itself, then starting with C++ can be very difficult. In which case, I would suggest you start with C and then you can start C++. And if you want to start learning C, then there is the C programming language book by Dennis Ritchie and Brian Kernighan. And yes, they are the people. Dennis Ritchie is the man who created the C language. Yeah, this book, can read this book to start with C. That would be nice. And so shit, this thing is messed up. Parse length, write to read from. Okay, this here we have n is equal to 4. This is the only time we are doing this. And printf, are we okay? We are printing also the length here, and maybe shit, this might be the function which is giving us error, which was like printing the false. Run the server again, right? And go to pipeline tester, compile, okay, we are still seeing 4. And the only place which is saying this is this. Um, uh, we are here, and yes, we are here. We are here. So, okay, we are here. The problem is with this thing here, we are here, and n is equal to 4. RV is also equal to 4. And here we are changing the size of n by n minus RV. So what can be the problem. After this, a little space and then RB. Okay, 4, 4. Both of them are equal to 4. Wait, shit. Maybe we are exiting out of this statement, and the only function that is calling this function again and again is this. Okay. Read n. Okay, this is returning something. What is this function returning? This function is returning 0. And in this case, this function is returning -1. And here we are checking if n is less than 0, which is -1. Then return this. But that is not the case. While rem is this. Shit. Okay. Shit. We don't need a while loop here. We do not need a while. Shit. Shit. Okay. We do not need a while loop there. We do not need rem this or that. Yes, shit, we do not need any of this. We just need to read into this. How much? Yes, it's starting from here. We need to read 4 bytes. Yeah, shit. Okay, we don't need the while loop there. So this is nice. And then we will check for errors. If n, then p print error uh, cannot read length, new line. And then I guess exit. Yeah, we can exit after this. Otherwise, after getting the length, we will convert the length in the right format and return. And shit, okay, this might work now. Server says hello from the server, and we are seeing some strange symbols randomly. I think we are printing more than we should be printing. In this buffer, everything initially is equal to 0 and write everything. So something is wrong with the read from function. Here we are getting the length. The length is, I think, amazingly good. See out or standard out length std and line. Okay, length is 18, and here we have 1 2 3 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Okay, we are due to some reason reading one extra character from the input or some place. Why? Hello. 5th semester, third year. Hedge or career. Shit, my bad, cannot read. And okay, read from, and we are able to read, but we are reading one more than we should be reading. And because the length is wrong, length is one greater than it should be. And is the problem on the server or on the client? The server and the client. Shit. And also, let's add back connection closing from the client. Exit. Let's see if this works. Undefined cannot read. Yes. Yes. Makes sense. We do not want to read for the last thing. Let's say S, right? If s equals exit, then break. Like, yeah, do not read because there is nothing to read. Wait, and even if the okay, shit, ChatGPT, if we have a connection, yo, hello, if we have a connection from between two peers and one has written something, right? For example, here, let's say we have the client and also we have the server, right? Client and the server, and they are connected on some connection, and server has written a bunch of things onto this socket which the client hasn't read yet. Client is like going to read it in a while, but before the client reads things from the socket, the server has closed the connection. Will the client be able to read things? Let's see. Uh, if shit, if a server and a client are connected on a socket connection, and the server writes some things on the socket, and the client has not yet read from the socket, and before the client reads, the server closes the connection. Will the client still be able to read from the socket? Excellent question. Yes, amazing, genius question. ChatGPT praises always. Server and client are connected via TCP connection. Yes, server writes some data using send or write. Client hasn't read. The server then closes its connection. Yep, situation recap. Brain, yes, brain. What actually happens? TCP level view. Okay, let's go. When the server calls close on the following connection, the following sequence occurs. All pending data that server has written but not yet acknowledged by the client is still sent over the TCP connection. Okay, shit. Oh, yes, makes sense. The connection is closed from the application layer, but everything in the TCP layer is handled by the kernel. Okay, and this is TCP. Okay, it has to be acknowledged. Every package that is sent has to be acknowledged that the client received the package. That makes sense. Then the kernel buffers the data and ensures it is delivered before the connection is fully closed. TCP guarantees reliable delivery of all bytes sent before closed. Okay, makes sense. After sending all the pending data, TCP sends finished packet to the client. This means I am done sending. No more data will come after what is already sent. On the client side, when it reads from the socket, it will receive all the data that was sent before fin. Fin is finished, I suppose. Finish as in not Finland, but finished. Then when it reads again from consuming, after consuming all the buffer data, it will get 0 bytes indicating end of file, meaning the connection has been closed on the remote side. Okay, so the server can close the connection after writing all the data, so that is cool. But UDP might, yes, UDP is a bad person. Yeah, UDP doesn't care, though I'm not sure. I'm not a web developer, thankfully. No, don't say thankfully everything. You're talking to me on web. Huh? Web is pretty nice. At least this part. We can, yeah, do a lot of things with Gradle. So that is pretty cool. Okay, so that is cool. That is cool. So the server can close the connection without worries because we have TCP. But TCP got our back. Okay, so yes. And we are somehow just reading one extra byte of memory and JKLM. Wait, is this random? And OPQR, no, this is not random. This is literally not random. STU, the next one should be VWXYZ, VWXYZ, not Z, Z and, okay, this is ASCII. So why are we reading one more byte than we should be? Here we are seeing that the length is 18, turns out to be 18, even though it is not 18. We have the event loop, but this is a part of the application code. And here the server is sending hello from server. Let's reduce this, and now it should be 5. And also we are calling get res function, which is right here. Get res function takes the string and res40. Okay, res is a vector of which stores 4 bytes of which are unsigned integers. Yeah, it has just 4 bytes, and put length, this much length, into res. Put length function is like right here. This takes in a length and then this thing. Let's see what is the length. Length should be 5, and yeah, this implementation is pretty cool. This is fine. So no problem with this. Let SVD out. And line and uh, IO string. And we have to stop the server, recompile the server, event loop, run the server. Okay, server is listening. Go to the client, run the client. Length is 6. Okay, so still one more than it should be, and here the client in the server is also saying 6, so there is no problem with the client. The problem is with the server. Application code, the problem is with the server, so yes. Okay, are you using any virtual machine to make this project? Nope, I'm not using virtual machine, but virtual machines are pretty cool, like very cool. Here, VM boot, I have made a little like command alias which I run, and then a virtual machine boots up and it is running. CPU usage is amazing. Yep, this is a virtual machine. This is running Debian. And right now I am in the terminal for the virtual machine. And yes, which is crazy. I'm running QEM to run this virtual machine, and it is literally running. And if I do beat off, I can see everything here. This has one CPU core, which is just running 2% capacity and 2 GBs of memory. This is everything that with the virtual machine. And look at this. The btop command is taking most amount of memory, which is this much. Command name, PID, sort. Okay, I cannot sort according to memory somehow. Yeah, I can sort. System D. This is amazing. Yeah, virtual machine is pretty cool. And now I like to shut down this virtual machine. Now. And the virtual machine is off, and now I'm in my base terminal, which is pretty cool. Especially React, I like Svelte, shit. React literally asks you to use Next.js officially, EFIK, and you need to install like HM hundreds of MBs before even writing anything. Next is, but one thing about Next, which is cool, is the docs. Look at this. This is very beautiful. This is very beautiful. Look at this. These are beautiful docs. These documentation. Yeah, these are beautiful. Can you guide me in making this on Windows? Can I use? I'm pretty sure I need Linux or Mac OS for running Redis from scratch. I don't think uh, you need to be able to access sockets, but yeah, whatever the case, I think you can just use WSL to run Linux there. Doesn't tell you how it works. It is telling you how it works, and you can use WSL and start Linux on your Windows machine, which is almost native performance because it is in the operating system itself. So that would be nice. Redis using Docker or WSL. Yeah, run WSL, or I don't know about Docker. I haven't used Docker, so I won't know. I haven't used WSL, so I don't even know how to use a WSL. But yeah, you can run Linux and then run do Redis project on that. And also, I used the strace command, and it is pretty cool on Linux on the VM. Strace is pretty cool. You can see all the syscalls which are being made, so that is cool. And okay, the problem is the server. The server is the problem. The server is not sending the correct size somehow. Process payload. Okay, shit. Yeah, we were using this at some point or something. Get response application.cpp application. Okay. Yep. Handle the server is messing up. After this, get response. Shit, I think it was because I was doing +I there. Shit, yes, it was because of +I. So yeah. Okay, okay, shit, okay. And G++, event loop, output server, run the server, which we can run right here, run the server, and here go to the project, run the client, run the client, and the client is again messing up, which makes sense, which makes so much sense. Because we have to compile the client here, we will running the client in another folder. So yes, and also here we are doing C out somewhere, which is here, G++, event loop, output server, run the server. Okay, and here pipeline tester is the client dot slash client, and everything is cool. Yep. The client says first, second, third, fourth, and the server says hello, 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 hello again and again. So this is cool. And the connection with client is now closed. We can write something similar on the client side also, which tells us that the server is closed. Pipeline tester here. Yeah. Here instead of just breaking, we can say printf connection closed now, and then break. Pipeline tester client. Okay. Run the client, and okay, at the end we do see connection closed, but you also have to add a new line there after closing the connection. Yep, cool. Yeah, this is working. This is working, and connection with client is now closed. And what I want to add to this is this print IP address of the client to which the server is connected to. That would be pretty nice. And does it tell you how in the JSX compiles to JavaScript? And why can't you install direct React and use it? Why does the website asks you to use Next.js or something? Yeah, look, Stray says amazing. And Next.js, I'm not going to defend JavaScript in any way. Search up Madwise. It is pretty fun too in Linux. And I also have to look up mmap command. Mmap Madwise gives advice about the use of memory. Shit, memory advice. Can I use it here? Okay, it does not exist here. But we have some other thing where we can check this out. Just boot up the virtual machine whenever I want to run Linux. Yep, it is on. What else? Password and or advice command not found. Uh-huh. Okay. Shit, unable to locate package. It is not there. Shit, my bad. VISE shit. Uh, and VISE advice. Okay, it is here. Gives advice. It is even in the library. Mman system call is used to give advice or directions to the kernel about the address range beginning at the address. I will look this up in my time. Man advice. Yeah, cool. Yeah, search with man advice. I used this for memory optimization. What? Okay, bro learned everything for this one challenge. That is crazy. Then shifted to Windows. SSD is using Windows and HDD, where Linux was hitting its bottleneck. Wait, SSD is using Windows and HDD hard disk drive, solid state disk. Okay, it is great for optimization ahead of time. So ahead of time, we can tell what we need and give some advice, I suppose. That is nice. I will look this up. I will look up what this command means. Shut down now. Yeah, back. Attach to miss. And what we need now is to do this thing. Print IP address of the client to which we are connected to, for which we will need to call a function. And this has to go on the application side and not just this. We will have to change this structure also. Yes, we will need get the function that we need to call now is called inet underscore n to p. Right. Yep. This is the function, and if there are a few this function. If you give this function the IP address in binary representation, then this will convert that IP address into presentable IP address, the way that we see it, like 225 255 dot something x number dot x some numbers. So this is how we read IP addresses, and the way that computers read are just zeros, ones, zeros, and ones. So if we give this form of IP address to this function, it will convert it into this readable form, and this is what I want to print. So let's see. And also I would like to print the same thing when a connection is closed. So we will need to store the thing into this state, and this function takes in a few arguments. First of all, character pointer, length of the character pointer, and also the protocol AF INET, which is for IPv4, and then the structure which is storing, yeah, which is storing the thing. And shit, this structure has to be where the IP address is being stored, and this structure that we have to send in is part of this struct adder or socket adder. This structure that you have to pass in is part of this thing. And when we are making a new connection in handle connection, which is all client-side code, application.cpp, handle accept. Here, this structure contains the thing. Yeah, this is the structure, and here, if we do adder dot sn adder, this is what we need in our structure. But what would be the type of this thing? Field sn adder, that is the only field, and public sn adder, sn adder, sn adder, sn adder, sn adder, in adder, sn adder. We have to update the state, this thing, and let's add event loop to harpoon and pipeline tester, application side code. Okay, here we have to change the state somehow so that it is better, and it is great for optimization. Yeah, because I want to get it below 2 seconds, but I think I'm stuck at 4.825. Okay, shit, bro is actively trying, I suppose. And oh yeah, I was making a TCP server in Windows yesterday with Win32 API, and surprisingly enough, as much of a smart person okay, uh, tick Microsoft is, their C++ API and headers are well documented. Okay, that is pretty nice. Go to the header file and grep it. Use auto. I could use auto header file and grep it. That makes more sense. I think there is a type of shit. Yes, we can use type of. We can use type of. But how do we use type of? Here, I think struct uh, sock adder in dot sn. Can we do this? Yeah, I think we can, instead of this, we can here say auto adder dot sn addr dot adder auto x equals to this thing. And what is the type of x? The type of x is unsigned integer. Shit, it is literally unsigned integer. So we can just pass in the integer and we can store the address as an integer, which makes sense. Type is in adder t. In adder t. So in adder t and adder. Initially, let's say 0. That is pretty nice. That is pretty nice. So whenever we are creating a new connection here, handle except after creating a connection and making this thing, what we'll do is here connection adder, we'll make the address equal to not client file descriptor adder dot sn adder dot, yeah, any compatible, incompatible man np inet network to presentation, something like this. Yes, it does exist. So here n2p, yep, inet n2p. First is the type, second is a void pointer src. Okay, source void pointer restrict something. Here we say auto x equals adder dot send adder. Now what is the type of x now? X is struct in adder. Okay, struct in adder, that is the type. Struct in adder, and yeah. Okay, it was not available. Okay, now it is. Makes sense. And yes, handle except we have to add this connection address equals adder dot sn adder. Okay, now we have the address in the address space. So let's grab it from the file, and that will be better for learning experience. And shit, I think I don't have the capabilities. How do I go there? Yeah. I don't have go to definition. My bad. I think I can have it plugins lsp config. Go to definition. Yeah, go to definition, control and right bracket. Okay, let's go to definition for this thing, control and oh, no, I don't go there. Shit, I'm pressing shift. Shit. Okay, this works. This works. We are right here. This works. It does work. Okay, let's go to definition for this thing. Uh, Socket adder here and control and right bracket. Shit, let's go. In adder, type of this thing is struct in adder. Yes, it works. It works. There must be something like include directory in the system that contains all the standard libraries headers. Yep, it is here. It is here. It is working. This is working. In.h, we are literally in the file which has this definition. So yeah, this is working. Just go there and press control right bracket Space GD. I think space GD would make more sense. LSP config, and I'll change this to leader GD. Go to definition. And I don't think I'm using this for anything else. But it would be much better if I could use a single character. Control G? No, no. Control T. Uh, Control N, I think would somehow make sense. Control N. No, no. Control I. Let's say Control I. Okay. Application.cpp, and if I press Control I on anything, I'll be there. That is pretty nice. Control O to go back and Control I to go inside. Okay, I makes sense. I can think of I as go to inside. That makes sense. And the key map, Control GD. Shit. That is what I was thinking. But you two have done the same too. Okay, I use it a lot, and it is really very handy to just quickly see the signature or something. And I changed it from Control GD to be a single character because pressing two characters G and D feels like too much work. And now I just have to press Control I to go inside, and I don't think I is being used somewhere else. And on the right of I have O to go back, Control I to go in, Control O to go back, which is pretty nice. Cool. Okay, so this is working. We have this, and we have to implement on accept connection. Yeah, handle accept. Here we also have the address. Wait, I think instead of storing this, we would be much better off storing a character pointer which contains the whole address instead of storing the address in a binary sense, because we can just print this character pointer later. Yeah, that makes sense. So yeah, here we have the address. We would have to create a new struct on the heap. Shit. And okay, not heap, char pointer add struct equals new char. And how do we call the new function with some specific size? I think we just do adder strlen sterling. That is the thing, I think. Sock adder length. uh, Handle accept, and okay, sock adder length. Shit, there is a function which we there is a lol. Yeah, what is you trying to achieve? I thought the server was working fine. Yes, the server is working fine. Right now I want to print the IP address of the client which is connecting to the server, and when the client exits the connection, when the connection is closed, then also the server should say connection closed with this client, and then the IP address of the client. That would be nice. And yep, shit, this doesn't work. Beats guide. I saw this function today, no, yesterday. I just want to use this. here there was, I just don't remember, there is a variable which stores the length of the IP address that we want, yeah, of the IP address. I think inet address length. Yes, inet address length. New and shit. How do we malloc space? Character pointer size of char into inet adder stir length. Okay. Expected a type. Okay, shit. But new char, we don't just want a char. How do I say how to give size to new in C++? I want this thing and this much of this thing. New, this thing, this. Okay. New char and how many? Inet adder stir length. Cool. Makes sense. And now we can call the function inet n to p, which means network to presentation, and it is not here man inet np. It is in ARPA inet. Header file include inet.h. Inet as in internet. Yep. Here the first thing has to be the protocol AF inet, that is the protocol, and then the address, I think address of addr dot sn adder, and like this, kind of like this. Yep. And now will be the adder string, the place where you want to store the character representation of the address and how much, what is the size of this thing. Uh, Add stir, and now we will say in the connection adder equals add stir. Cool. And now we will say new connection connected or something. Yes. Printf new connection established with an IP address which is add stir. And we will say add stir. Since we need a new line character at the end of this thing, we will say +1. And here we will say inet add stir equals 0, which is null character at the end of the string. So yeah, that is cool. And whenever we are closing a connection, which we are doing here, we will say before actually closing the connection, we will say connection closed with the string, and it is fps s dot add reference to value type. Remember reference, what is the error? Okay, shit, makes sense because fps is a pointer. Okay, this is cool. And before deleting this, we have to delete the memory in which we are storing that address. Delete fps s adder. Cool. So no memory leaks, and this seems cool. and this should now work. Hello, player. I think there was a socket address to string function or something like that. Or I think client dot adder family will tell me if the client is using IPv4 or IPv6. Client dot adder family or adder or something like that too. Happened to me. Why the fuck do I keep forgetting these things? Shit, bro is getting old, I suppose. And you haven't even gone to college. That is crazy. Event loop and output server dot slash server and here. Okay, connection started with this thing, ended with this thing, and that is pretty nice. That is pretty nice. Let's connect with. Let's change the client side code so that we can connect with multiple clients at the same time. Pipeline tester. Okay. Here we will not close the connection. And yeah, we will not close the connection. We will keep creating new connections, let's say. Pipeline tester main. Okay, shit. Let's say test. This is test. And yeah, this doesn't do anything, void. And here the function definition, void test. And in main, and let's say for in I equals 0, I less than 5, I plus plus, test, keep testing, and yeah, keep testing. Yes, and the sockets will only, and yes, every time this test function runs, we will get a new file descriptor. File descriptor will only be closed when this whole program ends. So that is cool. Now on the client side, compile the pipeline tester. Run the server, run the client, and okay, shit. Why are we running with the same? Why are we talking with the same? Okay, shit. The IP address is same. I think the port might be different. Let's also print the port. How do we print the port? The port should be a part of the IP address, I suppose. Yes. No, the port is there in a different data structure. Okay, sure. When we are making a new connection, here port is, yes, should the IP address would be same. That is stupid to think that it would change. But yeah, IP address would be the same. But here, adder.sn port, and the port is here. And can we convert the port from its numerical representation? No, yeah, we can just put the port there, or yeah, we can change this data structure to be a string, and this will free itself. So that is nice. And here, yes, we don't have to do this manually, so that is pretty nice. And here dot data. Yep, and here would be some errors. Wait, handle accept. Yes, right here. Handle accept. What we will do is, yeah, handle accept. When we get a new connection, we won't get this here. We'll say char address array, and the size is inet adder stir length, and initially everything is 0. Adder s string, and here you will pass this adder string, and you won't do this like this thing. What we will do is we will create a socket std string s, and s takes in, first of all, shit, can we send this thing like this? Shit, it does work, it does work. I think what we have to do is at least increase the size by 1. Okay, send in this thing, and then a comma or this thing, and then the port number, which is adder dot sn port. Nice. And then std string or s dot str connection adder dot data. Nice. Nice. That does work. That should work. Yeah, that should work. That should work. Hopefully. Or maybe not. Shit. Inside handle except we are doing dot data. Struct connection has no member. Adder addr does not exist. Okay. Addr does exist. What is this random I do know? And this seems to be cool. This should work, or it shouldn't. Shit. Adder struct con has no member adder, but it does have a thing called adder. Struct con has no member adder. Shit, it is right here. Adder. I even saved it. Shit, I think here in handle read, when we are doing this thing into this socket stream, when we are adding this thing, putting into the stream this thing, it is being treated as a number instead of a vector, instead of an array of characters, because this is literally a pointer right here. This is a pointer, so this might be bad. Yes, this might be bad, and we don't know the size of the port. Hmm. I think we can revert to what we had before, which is a character pointer, char pointer adder, and we will have an integer port, a port of the client, which makes sense. And shit, if that is the case, then we will have to delete the thing at the end of the s delete adder, and here we will have to make some changes. char pointer s adder equals new a new char like this. I think this was the syntax. Shit. New char inet s adder plus one. Yep, that is correct. And s adder inet adder stir length equals 0 to make the string to make the string small, to make the string null terminated. And here we will have to say s adder given the address on this thing. And what unit is this thing? S adder. Okay. So we have given the address, which makes sense. And now we also have to put in the port number. Port equals adder.sm port. And so we will say that this is the address, and then the port number is this. Connection port. This is the port number. Cool, makes sense. And we will do the same thing here. Digit FDS, yes, go there and print the port. G++ port event loop output server, and it compiles. Cool. Cannot bind, address is already in use and the server is listening. That is makes sense. That makes sense. That makes sense. Server is listening. Couldn't bind. If we couldn't bind, then exit. And also here, if couldn't listen, then also exit. Run the server here. Yep, the server is listening. Run the client, and okay, the port number is changing. And that makes sense. The port number is changing for the client for all of these 5 requests, which is cool. Which is cool. We are able to see the IP address of the client and also the port number from which the client is connecting. So that is cool. That's cool. And if we run here, the last IP address, the last port number was 37321. Let's, okay, it is changing. It is changing. And it is always increasing. So this is kind of running in a loop. It is increasing, and at a point when it is close to 64,000, it loops back to a small number. Let's go there. Yep, loops back. This loops back after 65,000. Okay, that is nice. So yep, we have debugged the code from yesterday, and we have added this functionality that the server prints the IP address and the port number of the client, which is currently connected. So that is cool. That is cool. And I think let's do crazy things. Okay, shit. Here, the server is not handling multiple clients at the same time. The server is handling clients like this, yeah. One after the another, because here in our pipeline tester function, this test function that we are calling 5 times, this is running one after the another, one after the other. So what we should do is, let's say we will create 5 sockets. First, we will create 5 connections, and then we will randomly keep sending requests from one or the other, and then keep receiving responses, so that it is more like an actual world, and that would be crazy. That would actually be crazy. Do you need, do you even the UDP don't get a fuck about packets, whether they are being properly sent or not, yet packet loss with UDP owes this person, while HTTP, it is even up to 95%. That is crazy. I guess because there is just, wait, these, I think you cannot compare UDP with HTTP 3, okay, because HTTP is an application level protocol and UDP is a transport layer protocol. You can implement HTTP on top of UDP, like at the same time. So if, yeah, that does not make sense, right? You cannot compare these two directly. And also, maybe by HTTP, you mean TCP, and that would make sense. I mean, low latency in UDP, low packet loss rate in UDP, because UDP does not send in any extra information. UDP just sends the packet and does not care, while TCP sends this packet and waits for the response to know whether the packet was received or not, which is, yeah, a lot of boilerplate. Yeah, for TCP, there is a lot of overhead. Pretty well that it was made for a faster connection, although, yeah, the speed indeed was fast, like very fast, but when you don't have to handle 10,000 packets, that is just the given. Lol. Include string header file, it is not able to recognize the string type. Okay, it is working. Ah, that makes sense in the structure. That makes sense. How did you make that arrow? What do you mean? If you're using C++, why don't you use cout rather than printf? It seems printf seems more convenient here. Okay, shit, something is bad here. By the pointer to the struct. Yes, we have a pointer to the structure, so we are doing the arrow. Shit, maybe you meant how is my terminal showing arrow here? Like when I do this thing, I'm getting an arrow. Instead, I should be getting something like this and then an arrow, then a bracket instead of a complete arrow. That is just the terminal. Ghosty. Ghosty is pretty cool. And also Ghosty does this if I print not equal to. So yeah, Ghosty does this instead of exclamation mark and equal to. That is cool. Create threads and make them request all at once you are just requesting. Threads won't be a bottleneck. HTTP 3 uses protocols which is based off of UDP, and I was just testing speeds of different protocols. Nope, not TCP. HTTP 3 doesn't use TCP, that is HTTP1 and HTTP use it uses, and packet loss with TCP is 0%. That is literally why it made yeah, it was made. So having 95% packet loss would be disastrous. Yes. Okay, so HTTP 3 is a transport layer protocol. Uses protocol with a base of UDP if it, but these are on the different layers of networking. UDP as is at transport layer and HTTP 3 is a different layer. So it is not HTTP's mistake for packet loss. HTTP, yeah, HTTP does not care about packet loss. It does not know about packet loss. Successor of HTTP 2. Yep, I think we can find its RFC. HTTP 3. Right here, IETF data tracker. Maybe this one. And yep, this is pretty new, considering internet is very old at this point, 2022. That is pretty new. Packet loss with this and this was 0% too, because they were based on TCP, right? You said that, and average packet loss was about 55% and median was 52% with HTTP 3. Okay, because it is based off UDP. Okay, so that is UDP's mistake. HTTP is cool. And now what we want to do is, yes, we want to create multiple connections, and you said we can use threads to do that. But UDP was this to this percent, and HTTP 3 is that much. Okay, which is crazy, which is crazy, which is crazy, which is crazy. Shit. Yes, it is crazy. UDP is like only this much, doesn't directly uses UDP. UDP's packet loss was this much, and HTTP3, which is based on UDP, has packet loss up to 95%. I suppose because in UDP, each packet is very small, and in HTTP3, I think if you have your like long response, right? Shit. Let's say you have your whole HTML page or something, and in, let's say, for from the perspective of UDP protocol, if let's say there are 1 million packets in this, and there were and you have divided this whole document into small packets, and you missed a few packets here and there, and let's say UDP lost in percent, 0 point some percent, very small percent. But then from the perspective of HTTP3, even if a single packet is lost out of this million, I think HTTP3 would consider the whole thing gone, because for HTTP to process the whole thing, it needs the whole thing, right? And I think HTTP, if from this whole page, even if a single byte of character is lost from 1 million, I think HTTP3 would consider the whole thing as lost. And I think that might be the case. Uses UDP under the hood. Nope, response was same for all. I was using 40 MB data with each packet, okay, of size being 64 bytes. I was using 40 MB of data. Okay, you were sending 40 MBs of data with packet size being 64 bytes. Yep. So yeah, I think this same argument is still is valid. The size of each packet you are saying is 64 bytes, and the whole document is 40 MB. And even if few packets are missing here and there, UDP would consider only those packets as lost, and HTTP3 would consider the whole thing lost, because how would HTTP uh, like parse the thing if there are characters missing here and there? That would not make sense, right? If the header is missing, if a few characters are missing from the header, then from HTTP's perspective, they are gone. The whole thing is gone. HTTP cannot do anything about the whole thing. So it is gone. And yep, you have to modify this and threads. That makes sense. Shit, what we can do is before writing, let's we have the sleep function. Let's import a random function. How do I get random number? Random numbers in C++ so that I can make these threads sleep at random times, right? Random. C standard library, srand time. We are using time as the seed, okay. And a random number is this. Okay, modern C++, include random, create a random number engine by calling this is the type engine, and okay, MT19937 shit, and chrono high resolution clock now, get the time, dot since epoch dot count. Okay, that would be our seed, and this is the type, this is our engine, and then we can use our engine. How do we get numbers from our engine? Define a distribution. Shit, we have to define a distribution. Distribution is this uniform integer distribution of type integer. This is from here to here. Okay, and then a random number would be this. Give this engine to the distribution and get a random number. Okay, we can do that. We can do that. Chrono and include random and include thread. And yes, each thread will have its own random function, and these things will be called std thread, new thread, and the function test is the function, and we do new thread dot detach before exiting pool, and okay, hereafter establishing a connection is here engine std 199 mt19937 engine, and this gets std chrono high resolution clock now, dot time since epoch and count. We have our engine, and we have to create a distribution uniform integer distribution distribution of integer dis for 1 to 10 seconds. So 10 seconds can actually be pretty high, let's say 5 seconds. And okay, we will introduce sleep here. Can we use the sleep function? Sleep for dist in time. Yeah, cool. I think that is pretty nice. That should work. I was counting the lost via client. Okay, how much packets did the client received? Okay, although it is pretty useless for what you are doing right now, but the finding was interesting. So I just, yeah, of course, thank you for sharing. Yeah, but I think, and I think not, but I think, and I think this might be the reason. Just after losing a few packets, HTTP3 is considered the whole thing as gone, because otherwise it would not make sense if everything is going there, which is going there. UDP layer is saying, like, here we have the server, we have the client, and this is the UDP layer. Let's say, even though it is not UDP, but something similar, but yes, it is UDP. So UDP layer, let's say this is client, on the client side is saying I got 99.9% of things, and those 99.9% of things, when they pass on to HTTP3 layer, This HTTP 3 layer is saying, No, bro, 95% things are gone. I don't have anything." So, yeah. Hello, Walrus 137. Hello, how is everything going? Sports, dungeons. Okay, let's run this. Pipeline tester, client dot slash client. Is the server running? No, the server is not running. QV is the thing is still going on. We established 1, 2, 3, 4 connections, and one of the connections said this, client says this. I think instead of client, I should print the IP address on the server side. Application.cpp, handle read, process payload in the process payload part. But shit, process payload does not, it has the connection, so that is nice. Okay. Here client says this, instead of client says, we should say %s, %d says something where, no, uh, connection are address and connection port. Cool. G++ event loop, which is the server, run the server. Are you good enough or interested in building the backend of my casino? Shit, 1000 budget. I have SRS and STD docs ready. Okay, I guess we would have to talk at Discord would be nice. Yeah, we can talk on Discord and discuss more clearly there. And let's run the server. Go to here, G++, client. Yeah, client is already compiled. Okay, everything is, every connection does start and every connection does end. That is pretty nice. This one, 583, it was the first one to establish a connection and it said yes first. Okay, that is nice. Let's increase the size of the random distribution, which is right here, from 5 to, let's say, 10. Yeah, 10. Okay. G++, pipeline texture output, client dot slash client, run the client. Okay, we established, okay, we have established a few connections, but they are not, yeah, they didn't close. The whole thing stopped. Why? We were just able to make 3 connections. I think threads, what is your Discord? It's the same name, Walrus on Discord. Message me, I am this, and is the Discord link is in the description of the video and the description of the challenge of the channel, not challenge. And this is your name. Okay. Run with the stream. Ping me. Yep. Hello. How is everything going? You got back your laptop, I hope. I think here the problem is that this function is exiting, right? So we need to keep this open. Let's say we will make this function sleep for 30 seconds. Yeah, just, yeah, 30 seconds. That is nice. Server is listening and miss dot flash line connection reset by peer, which is messed up. And should I have to compile and run event loop pipeline tester. OU does not make sense. G++ pipeline tester output um, client clear and then the server connection closed with this person. Okay, things are going fine. I think I should also add some delay in sending the requests. That would be nice. Yo, that is cool. That is cool. Pretty nice. We should add some delay on this side too. Distribution, for which we should change this to 1 to 2 seconds of delay here. Uh, sleep distribution engine and the same delay while reading the requests. And the main thing sleeps for 30 seconds. G++ pipeline, that is the client. Yo, let's go. Okay. Yo, shit. Okay, this is going well. This is going well. Server is saying hello to everyone, and a few of the connections are stopping. That is nice. But they all, yeah, even though they were connected at the same time, something is not right. Shit, okay. Makes sense. Let's say we will have int I equals 0. We have to change the seed of the random engine for each of them. Plus I. We cannot use I because, wait, why? We can use I. Nice. Will we be able to use I inside this detached thread? I don't know. I think maybe because the thread and the main function share the same memory space. I think they will be able to access this I. So that is nice. I plus. Okay, and that is our distribution. And also before connecting, we will add delay, random delay. Let's say sleep, this distribution, and this engine. Pipeline and client. Okay, run the client. Okay, we established a connection and then a bunch of connections. Then randomly, people are sending requests and they are intermingling. That is nice. Okay, let's increase the number of clients from 5 to, let's go 20. That is nice. Clear, stop the server, clear, run the server. Okay, and here run the client. Okay, cool. And we have like 20 clients. Okay, yes, everyone is sending their own requests. New connections are being established. Okay, our server is amazing. Okay, it is working. It is working. Okay, the server is done doing everything. That is nice. And all the connections seem to be closed on the client side also. That is pretty cool. Is your project complete till part 1? And what are you going to do next? And when are your semester exams? I don't know when. I think even the college doesn't know when the semester exams are there. And nope, part 1 is not completed. We still have to do this part, key value pair. We have pretty much done the pipelining, so that is nice. Verify the optimization before strace. Okay, yeah, they're using strace or something. Optimizing non-blocking writes. Shit, strace. Strace is pretty nice. Vim, yes, Vim, NeoVim. I wanted to learn NeoVim, but Visual Studio had gotten hold of me. Get out of it. VS Code is bad. Can you set up NeoVim? I saw 4 to 5 people going disappointed. Uh, can you set up NeoVim? Going disappointed? What do you mean? If you want to use NeoVim, you can use the Kickstart configuration for NeoVim. You can start from here. This is pretty nice. A starting point for NeoVim that is small, single file, completely documented. Not a NeoVim distribution, but instead a starting point for your own configuration. You can have this as your configuration, and then you can slowly build your own configuration. I have my own configuration, but that would not make sense. This would be more easier to understand. Yep, they have in a .lua file, and this is the whole configuration, and they have documented everything. Like, yes, key map in normal mode, left key does this thing, moved to the left, everything. And this is what we have to do now. But nope, shit. Before that, we have to do this debug and test, which we were unable to do yesterday because of some bug. You know, many people come and tell you I can't configure well, can't open terminal and all. Mm, I guess if that is the problem in that case, I don't I don't know how I would help. I have seen mostly everyone versus code only. Everyone VS Code only. Yes, everyone uses VS Code, but yes, everyone uses VS Code. Yeah, but all the people that I see on YouTube, they use NeoVim or something similar. And circle of programmers that I see other than me is very small, and all of them somehow use the terminal. So I think in my head that everyone knows how to use terminal, and yes, and I think VS Code is just people make fun of VS Code and no one actually uses VS Code, but actually a lot of people use VS Code. Shit, and that is not very good. People should not use VS Code. VS Code is bad. Okay, you are not using VS Code. I'm using Visual Studio. I'm a C hash developer at a company. Shit. Okay, bro has a job. Shit, bro is earning money. That is nice. And yeah, you are using VS, not using VS Code, but Visual Studio, the same thing. The thing is that it is also a IDE and not terminal based. Yep. And if you want to use, I was also using VS Code at a point and like last year, and which is bad. I should not use VS Code, and I thought, and then I just deleted VS Code and started using NeoVim, even though I was unable to do a lot of things at the start. But yeah, slowly I got over it. I think you can do the same thing, but you cannot do the same thing. You are working at a company. You cannot just delete your IDE and increase your output, decrease your output. Then is not very good. You might get fired. Shit, you might get fired. You cannot just delete your IDE. Shit, you can begin by using some Vim motion extension. Visual Studio, and there must be some Vim motion extension for Visual Studio, and you can begin by practicing with this. This is pretty shit. Should you have to add a JSON file for this? Should there might be a plugin. I don't know how to add plugins there. Like the way you are building things, I will start side project. Yes, let's go. Just do it under the hood. Yeah, do it under the hood. Don't tell anyone. And then one day go to your office and start like boot up Vim, and everyone will be scared of you. What we learned in the previous chapter. Okay, we did do that. Debug and test. Okay, byte stream, and also shit, we just finished implementing this thing. Yeah, this part of the code where we are sending requests and then receiving task spanning. Now we will be using strace, this function call, this thing. And the problem with this is Mac does not have strace. So what we are going to do is we are going to boot up a virtual machine, and we will run Linux on that, and we will use strace there. And I would have to copy and paste my code there. I think, yeah, shit, I can just put this whole thing onto GitHub. Missed. Stop the server. Get status. Okay. Untracked files, pipeline tester. Okay. And application.cpp and application.cpp and event loop. And what are the other things that we might be using? Interactive client. We changed interactive client and struct. Okay. Added event, not event loop, added pipelining to event loop. What is this now? Git add. What is git diff client request? What is the difference here? We have added a few lines. String talk. Again, not everything. I don't want to add pipeline tester. Client request format interactive client. Updated client side code, and git add pipeline tester, and added threaded uh, client side tester for pipelining, for pipeline testing or something. Yes. Push origin master. Okay, and now I can simply kill server and VM. Boot up the VM, and everything is on GitHub. And nvmrc mist is the name, and I can just clone this thing, and the last commit is this thing. We just made this added threaded client-side tester for pipelining. So what do you do? Yes, I only use C# in Unity. Shit, Pro is making games. I don't see what else can we use C# for Arch, by the way, no, Debian. Arch is too much of a hassle in virtual machine because support, since I'm running this VM on ARM processor and there is not a lot of support for Pacman, which is the package manager for Arch for ARM based binaries. So that is not, yeah, that is a big problem. But it wouldn't be, this is just skill issues because I do get Git, I can download Git in Arch and then I can build from source. So that wouldn't be a problem. I would be able to build everything if I knew how to do that, but I don't know yet. So I'm using Debian right now. Full stack, mainly C. So, okay. Game dev? Nope. Not a game dev. Bro is making, I guess, Cyberpunk code bases. And this, right now, we are in the virtual machine and total CPU usage is just this much, which is pretty cool. Dev.com, my name somehow and missed. Yep, the whole project is here. Yep. Missed, yes. Let's first of all compile G++ event loop. Yes, output, call it server. It is compiling. Shit, I would also like to have tmux. Shit, how I need tmux. I need tmux. I need tmux. I need shit. I do need tmux because I need to run multiple terminal sessions. Shit, yes. And I hope tmux is there. Okay, tmux is there. Now I don't know the default bindings for tmux, so I can just download my own configuration. Wait, there is a repository I created. Yeah, tmux.config. Okay, tmux.config. Clone https:// github.com. My name, your baby, and tmux.conf. Conf. lscd tmux.conf. ls all. Yep, it is here. And move dot tmux dot config onto my root folder. Okay, go back, rmrf tmux dot config. Okay, and if I run tmux, I'm running tmux with my own keybinds. That is pretty nice. Okay, cd mist shit cd mist run the server, and this whole thing is going on in the virtual machine. So that is like pretty cool. That is pretty cool. This whole thing is happening in the virtual machine. That is cool. C++, pipeline tester, output, client, run the client. This whole thing is happening in the virtual machine. Here we have the server running. Here is the client is running. Server is saying hello to everyone. Shit, what I can actually do is instead of saying just hello, just say hello, not hello, but say hello and then the IP address and the port of the client. Shit, personalized. That would be very personalized thing. Go to the folder. Okay. N Uh, yes, pipeline tester. Should it is a server side thing, so not a client side thing. And application CPP, when I am generating the output, yep, instead of hello, we can say we have to pass in also string. Can I give in a character pointer? Connection adder ship. Okay, I can, and then plus this. Okay, it does also work, and then plus string port. That is a number. Number. How do I convert a number? Uh, integer to string. Integer to string. To string. Okay. Okay. We can test. Attach target missed. And then the client. Wait, the server is not running, so not yet. We have to compile the new server. Run the server. The server is listening. Run the client, and okay, we have established a lot of new connections, and we should be start, yeah, hello this. Okay, we should add a new space. After hello, we should add a space or something. Yeah, here, space. That is cool. That is cool. Okay. C++ event loop output. Run the server. Run the same client, and okay, all the connections are being made at the same time, which is kind of crazy but acceptable. Yes, server says hello this IP address and this. Okay, and get status, hit add, updated server message with push version master. Close this, git pull, and if some error comes, I won't know how to handle it. Okay, shit. Okay, it is working. That is nice. Event loop, output, server, compile, G++, pipeline tester. It will be called client. Go to the right, go to the left, run the server, and yes, this does happen. Like shit, this does happen from time to time. X, yes. Okay, go to the right, and here run the server. Shit. Okay, server is running there. It is not running there. CD missed. Run the server. Server is running. CD missed. Run the client. Okay, this is working, and this is in the VM. This is all happening in the virtual machine. What is happening in virtual machine? In the virtual machine, I downloaded or pulled from GitHub all the code that I have written in this project till now, and that is running in the virtual machine. And this is the virtual machine, what you are seeing in your on your screen right now. This terminal is connected to the virtual machine, like using QEMU, and I don't know how to prove it. Let's look at this. This is not the Mac root folder, and this is Linux, Debian to be more exact. We can go into the boot folder and see stuff. Look at this. This is Debian, yeah, which is nice, which is nice. This is in the virtual machine, which is like pretty cool. Okay, and now we booted up this virtual machine, which is only taking one core because we were supposed to use strace, which we cannot use on Mac. We can only use strace on Linux. Use strace command to verify that we are testing what we intended. Okay. Strace to see the syscalls. Run the server with the strace command, and whatever the output of the server is, put it into dev null, or we can use temp, right? The temp folder. You said about the temp folder at some point. Okay. cd this is mist dot slash or s trace, run the server output to dev null. Okay, that is a lot. And here at the top, mmap. Okay, I don't want to see mmap because there is just a lot of mmap. So what we can do is execute and trace equals not mmap, not mmap. We will not see the mmap call. Server dev null. We are not seeing mmap, now we are seeing mu nmap here. So at the start we are doing some things. Where do we start the socket? Okay, we are never starting the socket somehow. We are starting the socket here. And all of this before this was just loading the libraries which would be required. Okay, so we are creating a socket, and the file descriptor that we got for our socket was 3. And then for that 3 file descriptor on the socket layer, we added this option, and then we binded our socket with this input where this was the address, IP address, and this is the port for the IP address. And then we started to listen on that socket, and we said at a time there can be only 20 connections. Okay, and then f stat, I don't know what that function call is, but okay, and then poll. And now we are polling, or okay, we started to listen, and now we are polling. We are seeing for waiting for connections. We are waiting for connections to come in. So that is nice. Enter the event loop. Wake up to the accept. Wake up to accept a client connection. Okay, yes, poll. That is exactly what we are doing. And then accept when there is a client request. Let's run this on Tmux. Right? Yeah. S trace and S3 on server, the output can go to dev null. Okay, here we have our socket is listening, and now poll is being polled, and here we will say we will run the client, and shit, this will run a lot of clients because we have 20 clients. Let's change the client side code. Pipeline tester. Here you see we have just one client. And yeah, G++ pipeline code, say that it is the client. Okay. And then tmux will server tmux. Yeah, run tmux. Here run is trace on the server. Everything that we don't need will go to null. Yep. Here we are polling and dot slash client. Yes, that is cool. Service is this. Yeah, cool. So here should we cannot scroll back up, but here we can see after poll, which is the event loop function, our server is reading after poll. Here the server is reading poll, read, poll, read, poll, write. But at some point we started to write, then we read some more, and then we were reading, and at the last point we were writing. Yeah, so yeah, it is a like sometimes the server is reading, sometimes the server is writing. That is nice. Wake up from client, from the client note the pipeline request. Should it has the actual argument. That is nice. Read function. This thing. Okay, so you might be able to see what we are reading. Read it it. And in this call we were just reading null. Here we were reading 4. Read h. Here we said hello this thing, and h shit, we can literally see what we are reading. UTR. So we are reading small bytes, but when we are writing here, we are writing the whole thing, hello, and this IP address, and then we are writing here, and yeah, write one is standard output, which says hello server is listening, new connect. This is what we wrote, and then we stopped. Yeah, that is nice. This is working. So wake up to write 3 responses at once. File descriptor 3. Wake up multiple times to read a large request. Poll, break, read, read, poll, read. Okay, wake up multiple times to read large responses. So we were listening, then we woke up and we wrote. We were listening again, we woke up and we wrote, and we were listening again. Okay, so why are we looking at these things? I don't know why are we looking at these things. The client closes the connection, then the server closes as well. Okay, read this and close. So we must also be calling close, yes, close. And by coincidence, the file descriptor on the server side here is 4, and here also it is 4 by coincidence. So yeah. And now optimistic non-blocking writes. I don't know why we have to go through this, but anyways, we are good programmers. In a request response protocol, the client reads the response before sending the next request. Yes, the server can assume that the socket is ready to write when it receives a request because the client has consumed the previous writes. Because the client has, wait, the server can assume that the socket is ready to write when it receives a request because the client has consumed the previous writes. Okay, okay, okay. Yes, that is what we are supposing, and we are responding in this way only. So the server can blindly, I think blindly should be the correct word here. So the server can blindly write without waiting for the next loop iteration to save once is called. Makes sense if we can write and read at the same time to the same circuit, then socket, then we would do that. We would do that, right? Has a response, handle read. Outgoing size is greater than 0, then we don't want to read. Wait, why do we not want to read when we want to write? That is kind of crazy. We would like to do both at the same time. This assumption is false with the pipeline client. Client may not have started reading while the server is writing. So the write buffer can be full on the server side. For this to work, handle write must check for E again in case the socket is not ready. The socket is likely ready to write in a request response protocol. Try to write it without waiting for the next iteration. Handle write. I mean, if the server can write right now, so the server will write, but if cannot, then we will come back in the next iteration. This assumption is false. Verify this optimization. Okay, whatever. This better buffer handling. What is this? We used vector as a first in first out since we append to the back and remove from the front. Yes, and we are doing this appending on the back and removing from the front in case when we are writing, but when we are reading we are just appending at the end and then removing the whole thing. No shit, when we are reading we are also removing from the front the data which is related to one request. Appending to the back is efficient for dynamic arrays, but it doesn't reallocate each time. Its capacity grows exponentially to amortize the reallocation cost, but removing stuff from the front is non-efficient because it has to move the rest of the data each time. If the buffer contains many pipelined requests, removing one from the front uh, by one is n square. So we need a buffer type that can operate at both ends. Yes, buffer beginning, buffer end. Shit. Removing from the first from the front is advancing a pointer. No need. Shit, we don't need this type of optimization, I think, because this is too much complexity, I would say, to handle pointers. Working pointers with pointers is very tedious. Removing from the front is just advancing a pointer. Buffer begin, yeah, shit, that is too much work. Pointers appending to the back now has two operations: allocate a dynamic array or move the data to the front to make room. This is left as an exercise for the reader. No, we will not engage with this exercise. We will be writing our own queue essentially, which is too much work. And we can now safely move on to this thing, key value server, the next part in this series. And before we move on to that, I would like to go to the washroom. And also, what is left after this? This is not very big, but okay. Yes, this is what we will be implementing next. So that is cool. And I will be right back in a minute. You it's blue and key value server. Building our own Redis. This is the last chapter in the part 1, easy part. And that is nice. Okay. Request response message format. The starting with the current protocol, let's replace the message part with something meaningful. A key value store with just get, set, and delete commands. Okay, so what we will have is n str and then length and then str1. Okay, Redis request is a list of strings, just like a Linux command, representing a list as a chunk of bytes. In the task of deserialization, we will use the same length prefix scheme as the output message format. N star is the number of items in the list. Okay, N star is the number of items in the list, followed by each item. Okay. This will tell us, okay, shit, since the client can send multiple commands in a single request, then we have this n star, which will tell us in this particular request how many commands are there, and then we will have each command individually. And individually in each command, it begins with the length of the command and then the command itself, which could be get, which could be three commands, get, set, or delete. Okay. A Redis request is a string list of strings, just like a Linux command. Representing a list as a chunk of bytes is the task of deserialization. We will use the same prefix length scheme as the output message format. Okay. And star is the number of items in the list followed by each item. Each string item is again prefixed with its length. It may be tempting to just concatenate null terminated strings as or delimit them with spaces, but a delimited format will only cause problems because the data may contain the delimiter. Makes sense. For now, the response is just an integer status code and another string. Shit. Okay. This is what the client will say, and this is what the server will respond with. Some Redis command can return complex data types other than a single string, which we will implement later. For now, the response is just an integer status code and another string. Okay, shit. Okay, now we are getting into the actual Redis part. We have written a lot of networking things, which is nice. Shit, let me shut down my VM before I run VTalk first. 3% of the CPU is being used and most of the RAM is empty. That is nice. Um, yeah, sudo shut down H now. Let's go. Let's go. Yes. Target missed. Yeah. We are here now. What we have to do? We have a mechanism through which the client and the server, can talk among themselves. What we have to do now is like add some language to their conversation, make it a bit more complex. Okay, this is what the client will say, and this is what the server will say. And what is status and what is data? This thing makes sense, but what is status and what is data? For now, the response is just an integer status code and another string. Okay, we'll see what to do. 3 steps to handle a request. Parse the command, process the command, and generate a response. Append the response to the output buffer. Makes sense. Static bool try one request. Okay, when we are parsing the request, got one, do some application logic, got one request. Vector of strings, command. Okay, we will call this command and parse request. This is the request. Length would be, okay, after getting the length would be this. Okay, and want to close equals true if this thing is smaller than 0 and return false in case of error. Okay, and otherwise response rest do request. Okay, process the command, process this command and put the response here and send it back to the client. Okay, I don't want to read this, I want to write this before reading. All I want to see is what they mean by the status code which the server is supposed to give out. We'll have, we have something working. Status not found. Shit. So the things that the client can do, client has 3 connections now. Now client is going to send something like this. Count, first thing. Yeah, the thing that client sends is this. Okay. We have this, and this thing is divided, right? And yep. And here, these are 4 bits, 4 bytes of memory, and these are telling us the count, which is the number of commands which are there in this request. So this is number of commands, this count thing. And then after this, we will have CNT number of segments in this, or at least that is how we are supposed to parse this. They are going to be CNT number of commands, and within each command, let's divide the commands, command boundaries, and within each commands, we have it divided into 2 different places. First thing, it is also 4 bytes, and this thing is the actual command, CMD command. These 4 bytes, size of CMD, these 4 bytes are telling us the size of the CMD, and this is like the actual command. So yeah, this is what the client is going to send us, and the server is going to send back a string where the format is like this, where this is 4 bytes and this is a message, and these 4 bytes are some status code, and this is the actual message. And what I want to see here is what is the status code supposed to say, like, yeah, what does the status code mean? Serialize the response. Shit, this is trivial. Uh-huh. Okay. What does the status code mean that the server will be sending? Parse the request, not here. Process the command. Okay. Response would be like this, a status code and then the data. And I think we should be doing this. Shit, we should be doing this. Like since the client is sending us multiple requests, and these requests, there are three types of requests which we are allowing the client to send. They are get, set, and delete. I think del. These are the three requests which the client can send, and only get is the one which needs back a string. But the client could say get me multiple things instead of just one, right? In which case we would have to out send back to the client multiple strings. And how would the client differentiate between two strings? How would the client know? So prerequisite DC topic, I must learn to build Redis from scratch. I would say till now we have not used any DSA thing. Yeah, we are like at almost we are at the end of the first part of this course, of this whatever course or thing this is, and we have not used DSA at all. We have only used basic, yeah, basic DSA knowledge. But the most this whole thing was not DSA heavy, but this was network programming heavy. And this was like, yeah, very difficult in network programming terms. But this had nothing to do with DSA. The DSA part comes later here when we are building hash tables, balanced binary tree, and sorted list. So you don't have to care about DSA just yet. You can just start building. This is network programming heavy, and network programming was very difficult. This was very difficult to get right. This was not easy, but yeah, this was very fun also. This has been very fun, and I have learned a lot of things, and I hope other people have also learned a lot of new things. This was very cool, and this is the last chapter that is remaining, and I don't know if I will not be going through part 2 just yet, because I do not want to write hash tables by hand just yet, not right now. After this thing is done, probably tomorrow, yeah, I'll do this tomorrow on a stream. Yes. Or shit. Okay, I will do this today. Let's say, yeah, after the stream or maybe during the stream, if I am able to do this, then I will do this chapter 7 today. And from tomorrow, we can get back to competitive programming. No, part 1 is both client side and server side. This one, yeah, this is both client side and server side. But client side is very simple because like the client is just asking for data. So it is not doing very complex things. But I'd say, yeah, this is pretty simple. Yeah, not simple. You will learn a lot. You will learn a lot. You will learn literally a lot. Literally, this is pretty tough. You will learn a lot. But now it seems simple after going through this, how to create a socket and all that. And if after this thing, I will start competitive programming again from tomorrow. And I think in competitive programming, I should begin by like get back to it. Sure. My bad. Should, s- starting from dynamic programming. Shit, I am logged out. I suppose no one was able to see my password. Yes. We will begin with dynamic programming. I will solve all of these questions which I have solved, and I'll try to solve the ones which I haven't solved. That would be nice. And getting back to competitive programming would be nice. And yeah, so yeah, let's get to this thing. Right. So, okay, I understand what the client will send, but what is the server doing? What is this? What is this? What is status and what is data? Okay, let's read what they are doing and then we can write this thing. Yeah, this is not a GitHub thing. Yeah, I'm just reading this and writing this. We can start from here. First part. Okay, let's read this and then I will write the code either on stream or off stream, depending on how much time is there and as if I am in the position to do that. Shit, my laptop is going to die. And my phone is also going to die. Shit. Okay, at the same time. Shit. Okay, I messed up. Anyways, parse the command. These are the three things that the server has to do. Parse the command, process the command, and I would say in this part one, we have established a mode of communication between the server and the client so that they can talk to each other. And now in this last chapter on key value server, we are after having this way of transporting information in this last chapter, we are using that mode of transportation and we are like actually transporting something useful, key value server. And I guess in second part of this thing, we are optimizing it and making it better. The same thing, we are making it better. But yeah, but we are not changing the transportation thing, which we have already established and which is already pretty cool. It is using pipelining and all that. Pipelining, yes, it is using pipelining. Starting with the current protocol, pipelining and event loop. Starting with the current protocol, let's replace the message part with something very, yep, pass the command, process the command, and generate a response. Append. Okay, we have to first pass the command which the server got from the client. Then the server has to process the command and generate a response. Then append the response to the output buffer, and that is kind of it. We will have a vector of all the commands, and if parse requests, okay, then we will try to parse the commands. Okay, this is kind of a pseudocode. Let's look at this. Parse the request one. Length prefixed data is trivial to parse. Yes, it is very trivial, I would say. Parse request, which is the same function here. This takes in, first of all, a data pointer to the data, size of this data, and this thing, which is a vector of strings, which will have all the commands. What do we have? End is data plus size. Yes, end is data plus size makes sense. Yes, we already have data from the client. Okay, read view 32 data end from this to this much nstr. Shit, nstr is the length of the whole thing and not shit. Makes sense. NSTR is the length of the whole thing and not the number of commands which the client is asking us is the number of items in the list. Shit. NSTR is the number of items in the list. So I think we have to define this function, read U32 at some point. Yes, we are defining the function, which takes in, what is this syntax? Add, is this a pointer to a reference? This is a reference to a pointer. Okay, we have a constant unsigned integer pointer, unsigned 8-bit integer pointer, and we are taking a reference to that. Okay, and here we have this, the end of the pointer, and we are using this as a copy, but we are not copying this. Here we are taking a reference, but here we are taking a copy of the pointer. So we could have taken a copy here also, but anyways, and this is out, which is how much we have to read. Mem copy cur, which is, okay, shit, we are taking a reference here because we want the actual value here, which we are passing in data to change. And read 32. If cur plus 4 is greater than end, return false. And otherwise, mem copy, take 4 characters, cur plus equals 4 onto out. Copy the 4 characters onto out. Okay, this thing is not making sense. Okay, what are they even doing here? And str is the third thing that we are passing, and nstr is initially equal to 0. Okay, we are getting the number of items. Makes sense. Yes, we are getting the number of items. That makes sense. Makes sense. Okay, okay. After getting the number of items, we cannot, this by number of items, I mean the number of commands. Here, NSTR is the number of commands that the client wants the server to execute. And this thing cannot be greater than the max number of commands which the client is allowed for, and while out.size is smaller than str. While we still have commands, what we will do is get the length. Okay, get length for this current command. Okay, read U32, unsigned 32-bit integer. I read this from this, and this is the end of the data, and this is the place where you are supposed to read this U32 value. And after this, if we did not return, if we were able to get the length, what we will do is push back a new string and out dot back read str will read from this data, where this is the end of the data and this is how much we want to read, and this is the place where read str is supposed to add the string. But this is not very good. Trailing garbage. This is not very good. This is blocking request. So this is literally a blocking request, and blocking request is not very fast. I think returning 1 is okay. Returning 1 is okay. Parse request. Okay. Okay, shit. No, shit. Okay, if we return -1, then it is error and we will close this connection. We do not want to close the connection. Shit, this is not very loop, event loop uh, compliant. We cannot copy paste this exact same code because this is not very good. This will overwrite all the hard work that we have done in establishing an event loop. After this is what we were able to parse. Okay, we added some helper functions so we don't have to deal with array indexing all the time. This makes the code less error prone. Read str and read u32. Okay, and then process the command. This is a reference to a pointer. Yes, exactly what we thought. This is a reference to a pointer. And then processing the response. Response looks like this. Response looks like this. We have the status and the data which goes with it. The key value store is fake within STL map. Yes, I guess in the second part we will be establishing, making our own map instead of taking one from the standard library. This is our key value here, gdata, global data, do request, a response. This is the place where we will add the response, and this is a command. Okay, and if command dot size equals 2 and command 0 equals get. If we just have two commands and the first command is get command, in that case auto at g dot find hit. Okay, this makes more sense. Okay. If the okay, this makes more sense. Get this and find the value which the client is asking for in our database. And if we did not if we don't get the value, then we will say response is response not x, not present, not found, and then we will return. But if we did get the thing that we were looking for, we will say we will create a new string referencing to the thing that we want to return to the client, and out.data.assign 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 this whole thing. Okay. Else if this is not a get request, then if command size is equal to 3 and the first value is set, then we will say dot swap command 2. Shit, makes sense. We will get the current value for the key and we will swap it with the new value of the key and delete. If delete, then we will delete this key. Else output errors. Okay, that makes sense. That makes sense. Today, after 5 days, I am about to boot up my computer. Shit, why were you not using your computer? You can run Omarki on it, not Omarki. Omarki. Yes, this is nice, and this whole thing now makes sense. Phone is charging. Yes, this thing makes sense. Okay, and then serialize the response. Make response takes in response appends the length, then appends the status, appends the length, appends the status, and then the data itself, which you want to send. Okay, so shit. Okay. In abstract terms, this whole thing is there. The I get the whole protocol which we are supposed to implement. All we have to do now is just implement this whole thing. I think, yeah, we just have to implement this whole thing. That is it. And I don't think I'm in the right condition right now to just implement it. So we can goof around for a few minutes till it is 3 hours because I have to stream for at least 3 hours. That is a rule, kind of. So yeah. But yeah, I won't be implementing this right now. I don't feel like it right now. Shit, you fight when the necessity arises. Mm, yeah, not right now. Not right now. But yeah, I do get the whole thing which you are supposed to implement, and that is nice. That is nice. I think we can play a little bit of chess. If someone is there who plays chess, we send a request and we will play chess. If someone is in the chat out of the two people watching, if you want to play chess, we can play chess. Mm. Yep, chess. Do you play chess? Do you play chess? We will play chess, or we can do something cool for the next 8 minutes or so. And shit, chess, there is a bad, sad thing going on in chess right now. Daniel Naroditsky, yeah, and Kremnik, Vladimir Kremnik. Kremnik is a bad person. Yep. Or maybe I think, yes, yeah, he passed away. Danya. Shit, I haven't watched his playlist for beginners. If I had watched it, I would be like much better at chess. Hikaru said that he is one of the best players, best teachers of chess for people who are just beginning. So yeah, it would be pretty cool. Or if not chess, then I can play with the virtual machine, Team Skill Server, and not play. What I would like to do is establish. I don't think I can share the link. Shit, I can. Okay, so okay, you are ready to play chess. That is pretty nice. Um, this is my ID. Uh, my name and then 50, Satyendraga 50. You can send a request on this. We will play chess. Streamnet games. Shit. Okay, a little warm up. A little warm up before our game. No, shit. You can send the request, then we will play there. Game started. Okay. So I'm going to lose. Guess. I don't think I can share. Give your. Okay. Wait a minute. Uh, Yes. Mhm, mhm, mhm. Ah, okay. Shit. I think I'm losing. No, just 1 minute. Yo, I'm finished the game. Then, yeah, sure. Just 1 minute. I started the game. My mistake. Shit, I'm going to lose. This feels very bad. No, I'll win. I'll win. Low on time, but that is fine. Shit. I am in a winning position, but I don't know how to convert. Yes, bro is smart. Bro is smart. Shit, I lose on time. Um, shit. Yes, you can send in the request. Yes, you can send in the request. Yo, let's go. Okay, 10 minutes game. Shit. Uh, shit. Okay, okay. What? This is not you. You can send the request now. My bad. Yep, let's go. Shit. Pre-move. The audacity. Key set. How is it going? Yo, let's go. I used to play as a guest. This is amazing. This is fun. Shit, I might actually might. I said might win. Shit. Shit. Why did I not? Okay, shit. I started to speak too much. Shit, that was very retard behavior by me. Shit. That does not even make sense. That also does not make sense. This does. Okay. Queen sacrifice. Shit, I'm 11 points of material down. Ah, yes, makes sense. Nah, I'll lose. Shit, bro will move here, I guess. That's okay. Me too. Me too. We all do. Please play all the games that you started aborting too often. Melee. Yeah. Shit. No, don't have enough time. Shit. Ladder mate. GG. GG. Yes. Yes. But yes. Blunder. There was one blunder. The queen blunder. Yes. There was the queen blunder. Yes. Let's be friends. Okay. I played at a rating level of 300 and you played at 1250. Shit. Blunder. Yeah. My bad. Yes. That was it. That was it. That was it. And in this server, yes, we have created the underline. Yeah, GG. To you. I messed up. I messed up totally. I totally messed up. And this thing in this, we started in, like as a revision history for what we have done. We started from the introduction and we did some socket programming here, and we learned how to make sockets and what sockets are. Sockets are simply file descriptors. which you can use to communicate. And also standard in, standard out, and standard error are also file descriptors. Yes, and printf and yeah, printf and scanf are also internally calling read and write with standard in and out as the file descriptors. So that is pretty cool. And yep, and then we wrote a request response protocol, which was a very simple protocol where we are using 4 bytes at the start to describe the length of the message that is attached to like the next thing after those 4 bytes. Then we create, well, we didn't create any concurrency model. We just learned about that using multiple threads and programs to create a concurrency model is a bad idea. Instead, what we should do is use event loop. And then we implemented event loop, and implementing event loop was also pretty fun. Yeah, we use poll, call, and different things, and what is a event loop and how it functions. That was pretty cool. And now all we have to do is key value server. We have the transport layer, you could say transportation layer ready so that the server and the client can communicate with each other. All we have to do is this key value server. This is kind of like the protocol which the client and the server are going to use to communicate. And this is all that is remaining. And I guess I will do this off the stream, and from tomorrow I will start competitive programming. So that I am bad. I didn't play the best since didn't play the game since 4 years past. Shit, and bro still defeated. Yeah, finally onto something interesting part now. Yes, we will do competitive programming from tomorrow on, and I want to like get really good at competitive programming again. And after some time, we can, yeah, we will continue this and we will go the whole way, advanced topics, and that would be nice. She plays on it. Shit. She plays on it with you. Shit. My main account is 1800. That is crazy. Shit. 1800 is crazy. Shit. 1800 is crazy. 1800 rating is crazy. Actually crazy. Well, maybe not. I have a friend of a friend, this guy, Wali Muhammad, and look at his rating 2200 in rapid 2200. Currently, it is 1420. 1420. And I guess I will push it till 1600 and 1600 or maybe 1800, and it depends. But yeah, I want to jump a new rank at least 1600, and then I will continue this project on stream. No, I'm not that good. Not yet. Not yet. Not yet. Shit. It's over 8000. Yeah, that is the end of today's stream. This guy is like pretty cool. Look at this. Look at this. Wait, no, he is not a cheater. He is like an actual human being that I don't know, but he's a friend of a friend. He is in IIT, so yeah, he's something. Yes, it does exponentially get harder because I'm currently at 1204. I didn't do more. Yes, it does get harder. It is pretty easy to get here, I would say, if you have a like nice mathematical brain. But after this, it gets pretty hard. You have to specifically study in algorithms to get better. Abraham is full of, oh, okay, makes sense. Makes sense. I mean, I guess Kremnik was onto something, but yeah, Kremnik was not onto anything. He is just a bad human being, it seems. And his position, he is just abusing his position as a former world champion. Yeah, 1200 is kind of easy. But only if, I mean, since I would assume that you already have a brain, you are already used to doing computer things, so it is easy for you. But if for someone who doesn't even know what programming is, then it would be a bit difficult. But yeah, it is kind of an easy ride till 1200, but it gets harder after that. And also, recently, increasing rating has become is becoming more difficult over time because of cheating, and therefore lower rated problems are harder than they used to be. So yeah, that is also one factor. Well, some people do. Well, not me, but some people do, and Danya did. Like it affected him pretty badly. I don't know what programming is. Shit. If you don't know about what programming is, I would say you can do this course, CS50. This is a pretty nice course for beginners. You can do this course, and this is for free by Harvard University. This might help you. This might help you to get into programming, right? This might help you understand what keys you can type in your Kinesis keyboard to get something done on your computer. They won't do CFE in the, I mean, they can do, maybe some first year people do uh, competitive programming, code forces. Yes, do it. And yes, I would suggest after you are done with CS50, you can go to this thing. Yeah, and this is a pretty simple thing from scratch. Linux from scratch. This will teach you a few things. I shouldn't have left. Yeah, okay, you would have been able to increase your rating quite a bit, I guess. Yes, LFS, let's go. And now I will be able to create LFS here on my VM. That is pretty cool. Yes, a little too easy. And shit, there is also CLFS. Mm, shit, cross Linux from scratch. CLFS, which like to cross compile Linux from scratch. How much time did it took you to reach this level here? What do you mean? I mean, in programming, I'm currently no C, CPP, Python, no modules, HTML, CSS, JavaScript. Now currently learning code. Do you have any advice on shit? Okay, if you already know these things, then how would I be able to advise you? Like you already know more than me. I cannot say I know CPP because I don't think I know C++ that well to say that I know CPP, and I won't say that I know Python also. And I think I can say I know HTML and CSS, but I won't say that I know JavaScript and how Node works internally. And I think if you need advice, that would be to increase your standard for including things in the category of the things that you know. So being able to write hello world in a language, after being able to write hello world in a language, you should not say that you know that language. I'm just like assuming because I don't have more than this one text. So yeah, if that is your definition for knowing a language, I would say uplift that definition. Second time you have done this? What do you mean second time? Yes, Debian, Debian, Debian. I think everybody is ahead of me. What do you mean? Okay, should in this case, Debian, shit. I would say uh, there's a Jordan Peterson video about this, not Linux. Motivation. Jordan Peterson comparing to others. Stop comparing yourself to others. Right? Yeah, you can watch his couple of videos about this fact, and he would be able to explain this much better than me. And yeah, do not compare yourself to others because that is not a fair competition. Your only fair competition is with yourself. Yeah, shit, yes. They just did something and are now too afraid to touch it. Yes. I don't think there is even a single human being who knows how GCC works completely. Like, yeah, I don't think. I mean, yes, even Björn Stroustrup wouldn't know everything that is going on with GCC or, yeah, everything that is C++ is just too big for a single human brain. They just did something and are now afraid, yep, get a job. Yes, obviously not full language. Coding is way beyond that. Leaving CP in between, one, two. Uh, huh? Leaving CP in between, I'm beginning CP, one, two. No, Debian. Yes, Debian. And I, yeah, true. Learning programming is not the language, and perhaps some paradigms. I know GCC works, but how? Yeah, it just works. Don't touch it now. And yeah, that is it. And also, I would like to use Arch instead of Debian, but I cannot because Arch does not have ARM support. Isn't for me, actually. Haskell is pretty interesting. Huh. Don't make the mistake. What do you mean? Arch. Okay. I will make the mistake, you know, eating the forbidden fruit. I will do that. That would be pretty nice. Try to learn it once. And many of the concepts in modern languages come from it. Shit, I thought Haskell is a newer language. Haskell motto. 35 years ago, 1990. Okay, it is not, yeah, it is old. It is old. Use Fedora instead. Okay. The requirements of the operating system that I want to run is just this CLI. I just want CLI with Git. That is all I need from my operating system. Nothing else. Yes, R sounds cooler and it is not even 100% functional. I just need Git and I can get Git with the minimal version of Arch. But right now I don't know how to build things from scratch. And there is an article actually about that. All bookmarks. Shit, where is it? Where is it? Programming, yes. Shit, it is not. Here, LFS. In the LFS project, they were like, there was some article about how to build things from scratch. And once I've read that, I will be able to use Arch in my VM. QEMU can different architecture even with the host. But that is one more another thing that I do not want to do emulation. I only want visualization, virtualization. Emulation is very slow. Emulation is literally very slow. I did try it. Even with Arch, emulation is slow. Yes. And yeah, I mean, I don't have anything important to do, so Arch is the way. Let me ask you a question. Would you trust someone made in open source by random individuals or a properly organized? I would say, I think I won't trust, but the fact that other people are trusting is very reassuring. So, yeah, so that is like other people are doing it, so it must be okay. Right? No one is standing against it, so it must be okay. But yeah, I mean, yeah, after using Arch, I would be able to maybe say more about this statement beyond LFS is also something. Hints, patches. And there was an article about read online, and why is this too big? Shit, that was too big. Stable LFS introduction resources, I think is the thing. Nope. Mirror sites. Change logs. Why would I read change logs? Chapter 1, 2, 3, 4. How to build an LFS system. Um, there was an article about building things from scratch. Yes, I wouldn't want a company backing distro. We all know what Canonical tried with Ubuntu, and Richard Stallman said Ubuntu is bad. So I have been on ours for 8 years. I switched to Fedora 15 days back, and my brain is happy. Shit. 8 years of marriage and no love. That is crazy. I can trust even Void for once, but not Fedora or Ubuntu. Yo, let's go. Richard Stallman and prerequisites. Yes, I think it is here. How to build. Yeah, these are the two articles about building from scratch. Yes. Shit, Hyperland and everything. Shit, I would be able to flex my Hyperland. That would be crazy. Anyway, for today, this would be it. Yeah, yeah. I think that is good enough. The mine of the mine of information and building and installing software packages for Linux. Yes, and to just use this thing, all I need is CMake and Git. Is Flex. No, I think you would be able to flex quite a bit. So I know how to manually set up Arch completely. I prefer mental sanity. I mean, you don't have to do it every time, right? Just once, do it once, and you are okay. Or maybe if you don't want to, you can use Omaki. That is also nice. Hyperland Flex. Shit. How long has Hyperland been around? 90. Dex, Hyperland about page supporters and their documentation is also pretty cool. Hyperland Arch to provide a simple install Arch install. If you want sanity, why would you go out of the way to do that manually? Right? You have to do it manually at least once when it comes to Linux. I am top 0.5 shit. Subtle flex, and yes, I think he is right. He's right. He is right. He's right. Like he's not lying. He's right. We have the simple Arch install thing. I can do all those things on my own. Yeah, not using Arch is fine, but shitting because you have to do everything manually when one is not doing a job. Only for those with the time is just skill issues. If someone is working, then expected. Yeah, relax. Arch install is for kids. Yes, I also want to move from Arch install, but do not shit on Arch. You have been using it for 8 years, so you must have some loyalty. You have to have some loyalty towards Arch. 8 years, right? And yes, I would like to invite you, any of you, on Sunday. I think probably I will come on Discord, and me and my friends will be one of my friend. We will be doing some thing. We'll try to do something with LFS, and yes, if you would come and show flex your hyperland, that would be amazing. Yes, I do. This is same. This is same. Yeah, this is same. This is sanity, and now this. Decide one. What do you mean? Because every pseudo package, a package breaks. And shit, there are problems, but there are always problems, right? So don't shit on Arch. and shit, I have to go. And if there is anything else, and there always is something else. Evening, around evening, that would be nice. Which cracks the workflow. Wait, why would you be installing things while working? You have to configure your environment before working, right? Why would you be sudo pack manning new things while you are working? No, I don't think that the error rate is that high. No, and in 8 years you were like still looking at this as a problem. That is crazy. And shit, yeah, that would be it for today. This has been quite fun. Building, sure. Yeah, building new things from scratch. And Harper, look at this. Hyperland. This is pretty cool. And most of the time, you wouldn't even know SRU is update. Lol. Shit. Most of the time, you wouldn't even know about the package that broke unless you are too deep into the system, which I doubt even 0.1% of the people would be. But why would things break? Okay, I think I cannot say anything about this because I'm on Mac. I can brew install and it works. We're not using GPT and know how to read the error. You know what packages are missing. Okay, you were making an argument that you will get problems, and now you are saying they are easy to fix. So it is a good thing, right? You should be using Linux Arch then. No, I replied to previous message. Yeah, this thing about packages being broken. Well, anyways, I guess it is up to you. If you want to come, you can come on Sunday. We will do some crazy things, or at least try to do some crazy things with LFS and maybe brain rot ourselves, you know, and that would be fun. And for today, this would be the end. And thank you for being here. We did quite a few things, and yeah, thank you for being here. Bye.